Hey you guys, this is part 2 of lesson 3-4 for solving quadratics by factoring. So in this section of the lesson, we're going to talk about two unique types of polynomials. They are types that will allow us to use the difference of squares and the sum of squares. So what those look like are shown over here on the side. I'd like to start in the example column. I think it makes a little more sense to begin there. So if we look at this expression, x squared minus 49, what we can do is we can factor it into x plus 7 and x minus 7. What you might notice is that we are missing an x term. So it's like having a 0x minus 49. So if we use our previous rule of what multiplies to negative 49 but adds to 0, that would mean we're looking at positive 7 and negative 7. Positive 7 times negative 7 is negative 49. Positive 7 plus negative 7 is 0. Now, if we look at like the fancy mathy way of saying that, what they're going to show us is that if a squared minus b squared, pretty clutch minus here, if it's a squared minus b squared, then it's going to be a plus b, a minus b. What you'll notice is that basically, on the color, basically you just square root this, make one positive and one negative. Square root this, so you get x7, x7. You do a positive and a negative. The reason those signs need to offset is because a positive times a negative has to equal a negative. Okay? So if there's a plus sign between them, right here, it's not going to be a difference of squares. All right, and then the other option is the sum of squares. So that is what happens if you have the positive. So you'll notice it looks super similar. We can take the square root and the square root, and we have x and a 5, x and a 5. The problem is we can't have two opposites we can't have two opposites multiply to a negative. Basically, if you set this equal to 0, and you get x squared equals negative 25, and you try to square root, you end up with x equals 5i and negative 5i. That's why we have these two little nuggets in here, okay? But if you want to just memorize the rule will be a squared plus b squared, square root this. You got a, bi, and then a plus and a minus in between. So that would be the pattern. That might be something you'd want to put on like a study card or something like that. So here, when we solve for using the difference of squares or the perfect square, in my opinion, there's two ways you can solve this. When we're solving, we're trying to figure out what y equals. So, I mean, what I would do is I would just go y squared equals 36 and then square root both sides. And we would get y equals 6 and negative 6. But if you use this new trick or the new method that we just found out, you would make it equal to 0. Y squared minus 36 equals 0. This is a difference of two squares, or difference of squares, I guess is what some people say. I'll put DOS for difference of squares. So that means you're going to do square root y, square root 36. So you'll get y6, and then you'll do a positive and a negative equals 0. When you set both of those equal to 0, you get y equals 6 and negative 6. But as you can see, this method also works pretty quickly. Okay, if we do the same thing over here, pretty soon you guys will start to recognize like, oh, that's a difference of squares, and you can just write them down quickly. But this one has a minus sign in between. If it has a minus sign in between, that means we're looking at a difference of squares, just like up here. So difference of squares. So we're going to go x8, because the square root of x squared is x, square root of 64 is 8. x 8, and then a plus and a minus. Set that equal to 0, set that equal to 0. Solve, and you get x equals -8, x equals 8. I'm a little bit lazy, so probably what I would do in that case is I would just, again, we're trying to get x by itself. So I would add 64 on both sides. And then square root. Just make sure you know how to recognize the difference of two squares and how to use it. But in any case, you'll get the same solution no matter how you do it. So now if we move to these next ones, what you'll see here is this has a plus sign, just like this one, which means it's a sum of squares. So that means we're going to square root x, square root 4, square root x, square root 4. But we have to make sure we put an I on these because you'll see we have the i's. And I'll show you why in just a minute. But then you get plus minus. Set those both equal to 0. We get x equals -2i. Then if you set this equal to 0, you get 2i. Here's another way you could do it. If you're just solving for x, I would subtract 4, and then square root. Here's the reason you got to be careful. A lot of you guys are going to make a silly mistake, and you're going to be like, oh, it's 2 and -2, but you can't square root a negative. So it's going to be -2i and +2i. The I is what's important here. Okay? So these are your solutions. If you guys want to pause the video, maybe you can try this method. Try this example. See if you can figure out what the solutions are. Go ahead and pause the video. Okay, when we look at this one, we have a plus sign, which means it's a sum of squares. So we're going to go C 10i, C 10i, positive and a negative. Set those both equal to 0. You get x equals -10i and x equals 10i. Otherwise, you could go c squared equals 1. C squared plus 100 equals 0, minus 100, minus 100. C squared equals -100. Square root both sides, and you would get C equals 10i and -10i. So, two different ways of doing the same thing. It's just that this is the sum of squares method. The versions in pink are the sum of squares method. Okay, and then the last couple examples here are what we call factor the GCF, or greatest common factor. So basically pull out everything that you can that they share. So if you look at the numbers and the letters, so the coefficients and the variables, we want to see how many of the coefficient we can pull out, what they're both divisible by, and how many of the letter we can pull out, what they're both divisible by. So if we look at the coefficients, both of those numbers are divisible by 3. So I'm going to pull out a 3 in the front. Then I'm going to look at the variables, y squared and y. This means y times y. This means just y. I need to take the same amount from both of them. So I'm going to take out a y, because I can take one from here and take one from here. So what's going to be left is 9 divided by 3 is 3. We have this one single y left. And then, this is where it's going to be a little bit weird. 3 divided by 3 is 1. And we don't have any y's left. So what we're left with is 3y times 3y plus 1. Here's how you can check if you did it right. This is just a check. If you take this nugget, right, if you take this right here and you multiply it back through the parentheses, do you end up with 9y squared plus 3y? Well, 3y times 3y is 9y squared. 3y times 1 is 3y. That's what we started with, so yep, we are all good. Now you just set these two little nuggets equal to 0 and solve. Divide by 3, divide by 3, y is 0, minus 1, minus 1, 3y equals negative 1. Divide by 3, divide by 3, y equals negative 1/3. There we go. All right, this guy over here, what we need to do is first move the 20a over. So now we have 5a squared minus 20a equals 0. So now pause the video and see if you can pull out whatever you can pull out. So everybody pause it, give it a try, see if you can factor out the common stuff. Okay, so if we look at the 5 and the 20, what is the greatest common factor? What can both of them be divided by that's biggest? Well, in this case, it's 5. And then when you look at the variable, the a squared and the a, they're both divisible by a. That's the most we can take out of both of them. So 5 divided by 5 is 1. A squared divided by a is a. Negative 20 divided by 5 is negative 4. A divided by a is 1. So we get this. You can always, again, check if you redistribute. And then we can set these equal to 0. Divide by 5 on both sides, a is 0. And then add 4 on both sides, a is 4. What that means is if you put those into the original equation, it'll make two true statements. All right. The next one, if we look at the numbers 10 and negative 9, neither of those are divisible by like the same thing. So those are just stuck. No numbers will come out front. But if we look at this and this guy's got 3 x's, like x times x times x. This one has 2. That means maximum we can pull 2 out from both. We can pull 2 out from both. The first term, it still has our 10 there, and it started with xxx, but we took these 2 out. So we're left with just one more. Then minus 9, we couldn't change the coefficients, but we had 2 x's there. We took them out. That means that there's none left. So we close that off. Set these two things equal to 0. Add 9, add 9. Divide by 10, divide by 10. And then this one, square root, you get x equals 0. All right. Last one. So with this one, we don't have much in the way of variables, so we just look at the numbers, the coefficients, 15 and, well, 20 is a constant. So if we look at 15 and 20, what's the biggest that both can be divided by? That would be 5. And then what's left is 15 divided by 5 is 3. There's no letters shared, so we can't pull any variables out. So we have an x, and then 20 divided by 5 is 4. Again, you can always double check to see if you factored it correctly. This can never equal 0. So we can't set that piece equal to 0. All we need to do is go 3x plus 4 equals 0. Minus 4 minus 4. 3x equals negative 4. Divide by 3, divide by 3. X equals negative 4 over 3. And that is the only option, which makes sense because this equation is to the power of 1 up there. It's a linear equation. All right, so that is the end of lesson 3.4 or 3-4.